All right, team, this is going to be our last set of derivatives rules for a little bit. These are transcendental functions, which just means they're functions that are sort of beyond the basic polynomials that we've been running into. So things like exponentials and logarithms that you're familiar with for pre-calc. Next page we'll do a little bit of trig. E to the u, so the exponential function. You're going to like this one. The derivative of e to the u is e to the u. And then we're going to do chain rule, so times the derivative of whatever is up top. So essentially the derivative is itself, but I want to emphasize that you must remember to do chain rule if you have a function inside there. So the derivative of e to the x, Here, the derivative of e to the 2x minus 1, e to the 2x minus 1, times the derivative of 2x minus 1, which is times 2. Okay, so we'd say 2e, okay? So that is probably the easiest derivative rule to remember, but don't forget to do chain rule. The natural log, so the inverse of the exponential function, so the derivative of the natural log of something is 1 over something times the derivative of something. So we're doing chain rule in both cases. Okay, let's make a note of that. So chain rule, what I mean by du is the derivative of the inside in both cases. All right. So again, this one's pretty easy. So if y is the natural log of 2x plus 2, we're going to say the derivative is 1 over 2x plus 2 times the derivative of 2x plus 2, which is 2. So the result would be 2 over 2x plus 2. And even here I could simplify a little bit, but I don't need to, so I could pull a 2 out of top and bottom. And then 1 over x plus 1. But my unsimplified result is fine. We'll do another one, and again, we're going to do chain rule here. So f prime of x is going to be 1 over 2x squared minus 4x, and then times the derivative of the inside. Here, the derivative of the inside is 2 times 2 is 4x, minus the derivative of 4x is 4. Okay, and the way I'd want to write that is as a rational function. And again, I could simplify this, but we don't need to. Okay, so the main takeaway here is don't forget chain rule. Okay, so these rules are pretty easy to apply, but the most common way that students get them wrong is by forgetting chain rule. So don't forget chain rule. Other than that, these will go easily for you. All right, and then we're going to take a look at some trig functions. So these are going to take a little bit longer to memorize, obviously. By the way, these all come from the limit definition. Deriving them is a little bit beyond the scope of the course, but that's where they come from. So every time you see a derivative, we're still doing a limit. These are just, again, shortcuts. So the way I want you to tackle this is just keep this list handy and look them up as you need them. We'll wait a while before we make ourselves memorize them. You do need to have them memorized for the AP exam, though. So these examples, notice, I have a product here, I have a quotient here. So we're going to still use our rules we're familiar with. So product is f times g prime plus g times f prime, right? So the way that's going to look is x squared, to take the derivative here, x squared times the derivative of sine is cosine. So x squared times cosine x, that's f times g prime, plus sine times 2x is the derivative of x squared. So that's my derivative here. And then quotient rule, this one you probably don't have memorized quite yet. Maybe you do. You could find this in your notes. What it is, right, is the bottom function times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. This is obviously not the most rigorous way to write this, but it is an easy way to remember it. Okay, so the bottom function is x, so here's f prime. And then the top function is cosine. We're going to go to our rules and find that the derivative of cosine is negative sign. Don't forget that negative. Minus, top is cosine of x, times the derivative of the bottom. The derivative of the bottom is, of course, 1. And then all over. Obviously, we don't have to write this one. We can multiply this together. So negative x sine x minus cosine x all over x squared is my derivative here. Okay, here we just have a sum, right? So we can just do each term independently. So then remember that my square root of t is really t to the 1/2, and then I can use power rule. So my derivative, g prime of t, is going to be 1/2 t to the negative 1/2 by power rule. Should be easy for you now. Plus 4 is just chilling, it's a constant multiple. And then we need the derivative of secant. So derivative of secant is secant tangent from my list. So we do secant t. Okay. And then last one, ugly one. So we're going to do chain rule. So notice we have tangent of something. So we need to do the derivative of tangent of that thing times the derivative of that thing. Okay, so our inside function, let's do that to start. Our inside function is that e to the 2x squared minus 5. The derivative of that is that, right, because the derivative of e to the anything is itself. And then chain rule, the derivative of my exponent now is 2 times 2 is 4x. So that's the derivative of my inside. So whatever I get here for my derivative, I'm going to multiply by this by chain rule. This is a chain rule problem. Okay, so let's figure out what the derivative of tangent is from my list. Tangent is secant squared. So h prime of x here is going to be secant squared of e to the 2x squared minus 5, because the inside stays the same for chain rule, and then we multiply times that derivative of the inside, which we already did. 4e to the 2x squared minus 5. So that's my derivative of h prime. Okay, so even though we're making our functions more complicated here, our rules, product rule, quotient rule, and chain rule still apply.